and then we'll get started. Okay, so the last lesson we did together where my computer totally died, we were multiplying and dividing, and then you did a lesson on your own about subtracting and adding rational expressions. So just like when we're adding or subtracting normal fractions, we always need a common denominator. And that can be the hardest part of adding and subtracting rational expressions, or the piece that people just are really struggling to get from the get-go. So let's do some practice on finding our lowest common denominator. Now, one thing I want to mention is that similarly to fractions, if you don't have the lowest common denominator, that's okay. You'll still get the same answer. You'll just have to simplify more at the end. So if you just have a common denominator and it works, that's okay. Your answers will all still work out, so a little less pressure that way. So what we're going to start by doing is looking at these sets of numbers and trying to find the lowest common denominator. So basically, our denominator has to have all this stuff in it and all of this stuff in it. So in this case, lowest common denominator, it needs to have that 2 times 4x minus 1, and it also needs to have 3x. So our lowest common denominator will just have everything in it. If we're going through this and you're finding it a little bit confusing, sometimes I find the lowest common denominator almost easier to find in an example and to understand than just these. So sit tight if you're finding this a little confusing, or if it's really helping you, awesome. So for question B, let's find the lowest common denominator of these three expressions. So we have 3 times x minus 2, 5 times x plus 1, and 10 times x minus 2, x plus 3. So to start, our lowest common denominator must have 3x minus 2. Next, I'm going to do the 10 one, and you'll see why in a second. So then I need to include a 10. I already have an x minus 2, so there's no need to include that again. But I do need to include the x plus 3. And finally, for my middle one, I already have 10. And I can get a 10 from 5. I could just multiply it by 2. So we don't need to include the 5, but we do need to include the x plus 1. Now let's say you didn't notice that and you did include the 5. You will just have an extra factor of 5 running through. It's not the end of the world. Things will simplify at the end, so it's not a huge deal. It just does make your math easier and more simpler if you have the lowest common denominator. So that's our second example. Let's do one more. So when we're finding our lowest common denominator, we're multiplying things. And it's a lot easier to multiply things when they are factored, because we're trying to find the lowest common denominator. Similar to over here, how I already had an x minus 2. Oops, sorry. I don't want to double up on them if I don't have to. So let's start by doing some factoring of these. So x squared minus 4 is a difference of squares. So that factors to, oops, sorry, still on my highlighter, x plus 2, x minus 2. And now let's factor the x squared plus 5x plus 6. So for this one, we're looking for two numbers that add to our middle number, which is 5, and two numbers that multiply to our last number, which is 6. So in this case, we would have 2 and 3, 2 and 3. And because this expression starts with a 1, we just have a 1x squared, we can just factor 2, x plus 2, x plus 3. Now we can find our lowest common denominator much simpler. So we'll start with the first one. It has to include an x plus 2 and an x minus 2. And now if I look at the second one, I've already accounted for the x plus 2. I don't need to write that twice, so I'm going to just put the x plus 3. So that's our first little exercise of finding our lowest common denominators. Again, I actually think this is easier to see when we're doing it in an example, because sometimes when we're just finding the denominators, it's not clear how that would work in an example, so it kind of just feels a little random sometimes. So let's do a few specific examples. So for example 1, we're going to simplify this, and we need to state any restrictions. Don't forget that. So on our quiz tomorrow, if you do not state your restrictions, you will lose marks because that's an essential part of solving the problem. So if they're not there, you will notice that you lose marks for that. Okay, so we have m over 2m minus 4 minus 3 over 3m minus 6 plus 1. So the first thing we want to notice is what is hanging out underneath that 1. So there is just another 1 under there. I like to write that out because it helps me to remember that I also need to find a common denominator for the 1, and I need to treat it just like all of the others. So now let's think of what our lowest common denominator is. And when we start to find that, the first thing we want to do is we want to factor everything completely, just so that we don't accidentally double up on our denominator. That way we have our lowest denominator that makes things as simple as possible. So let's go through and factor what we can. So we can't factor that m in the numerator, so it's just going to live as an m. Now, in the denominator, I have 2m minus 4, which means I can factor out a 2 there. So let's go and do that. There we go. Now we have minus, we can't do anything with that 3, so it will just hang out for right now. And now our 3m minus 6, I can factor out a 3. So let's factor out 3, m minus 2, plus 1 over 1. Okay, so now let's find our lowest common denominator. So we want them all to match is our goal here. And I'm just going to find a different color so we can separate it a little bit. So our first term has 2 times m minus 2 on the bottom. In order for it to match the other ones, we're going to have to multiply it by a 3 from over in our second term and a 1 from over in our first term. If I do that to the denominator of a fraction, I also need to do it to the top. So we'll multiply it by 3 and by 1. You don't have to write the 1. I'm just trying to set up some steps and a process for you to do so that you could use this for any example. But if you want to write the 1, that's great. If you don't want to, you don't have to. Now for our second term, we have 3m minus 2. So from the first term, we will also need a 2. And then we'll also need to multiply it by a 1. If I do that on the bottom of the fraction, I must also do it to the top, like that. Now I'm going to look at my 1. What is it missing from the other ones? So to make it look like the first term, I need to give it a 2 and an m minus 2. And then to make it look like the second term, I already has the m minus 2 now, but I also need to multiply it by that 3 to make it match. Now in my numerator, if I multiply my denominator by this, I also need to multiply my numerator by that as well. So now let's go and write all of that out and take a look at our denominators. So on the top, we have 3m all over 6, m minus 2, minus 6 all over 6, m minus 2, plus 6, oops, forgot my bracket, m minus 2 all over 6, m minus 2. So all I've done is I've just worked through to make sure that they all have the same thing on the bottom. So again, what my steps were is I look at this and I see what it's missing from the one in front of it. So everything's the same, except it also needs this too. So that's kind of our idea. Now, just like with fractions, when I simplify adding and subtracting rationals, I keep my denominator and I just add and subtract my numerators. So this will give me 3m minus 6 plus 6m minus 2 all over. And remember, because we're adding and subtracting, we keep the denominator. Yes, Tirth, do you want to put your question into the chat? The restrictions, yes, we will get there. I'm just going through this part first, and we will go through the restrictions. We're going to do the restrictions for all of the steps, so we will get there. And if you would prefer, you can do the restrictions throughout. If that's a part of your process, that's totally okay. I know that the adding and subtracting can be really tough, so I'm just going to go through that first, and then we'll do the restrictions after. Okay, so now I'm going to simplify this numerator. So I have this 6 over here, so I need to multiply that into these brackets. We'll have 3m minus 6 plus 6m minus 12 all over 6m minus 2. And I'm not going to expand the denominator because I'm not trying to combine it with anything else. The reason why I'm expanding the numerator is because I want to add together this stuff, and I can only do that once I expand it. Okay, so now let's collect some like terms in the numerator. So we will have 9m plus 6, oops, sorry, minus 18. All over 6m minus 2. Now, to simplify, I'm going to factor as much as I can in the numerator. So I can take out a 3, actually I can take out a 9 here. I'm left with m minus 2 all over 6m minus 2. And now these lovely m minus 2's cancel. So we can get rid of those. And we're left with 9 over 6, which is equal to 3 over 2. And as always, if you don't want to write out every single one of these steps, that's okay. I just like to do it so that everyone can see it. Now, the restrictions. Can't forget about those. So for my restrictions, I need to make sure I find restrictions everywhere. So typically, that's why I like to do them as we go along. But just because the adding is so hard, I felt like it'd be disjointed if I started popping back and forth about restrictions. So anywhere where there is an m on the bottom, we need to address restrictions. So I kind of go through and I look here. And in the top here, from my first step, I have that m cannot equal 2. And if I keep looking, that is the only one. So that would be my final answer. So far, so good? Yes, Ethan. No, so you don't have to put restrictions every step. Just sometimes the restrictions change every step. So for example, sometimes something gets canceled out and goes away, just like even it did here. So we just need to make sure that even if it's gone away, that we still count them on every step. Sometimes if we're dividing too, something that was in the denominator turns to the numerator. So we need to make sure that if at some point it was on the bottom, that we've accounted it for a restriction. So that's usually why I tell you to do it as you go. But if you do it at the end, that's fine too. Dimitri? do we find restricted with 2m minus 4 and 3m minus 6? You can. You'll end up with the same thing, that it can't be 2. So if I go through, this is a really good question actually that I really want to address. So if I have 2m minus 4 and I want to see when that can be 0, just so everybody can see it, because that's actually a really good question. If I do this, I actually still get m equals 2. But that is a really good point to bring up, because if something does look different, you really should check it. So that is actually a really good thing. I'm happy you brought that up, because it works like that for here, but let's say you canceled something out, it might not. So that was a good point. Okay, any other questions? Oh, yeah, Sasha. So typically you do. If at any point, even including the original, there's an m on the bottom, we have to include it. In this case, those are also m equals 2. So it ends up being the exact same one, but that's a great question. Yeah, but anytime you have it on the bottom, you should. But when you factor it out, it's the exact same expression, just written in a different way. Yes, Keith. And then Ethan, you can also start typing in your question. So how do you know when to cancel out? That's a good question. So once I have everything all multiplied on top. So see here how there's a subtraction sign on, oh my gosh. See here how there's a subtraction sign on top? That means I cannot cancel out. So the only times I can cancel stuff if everything is multiplied. So here I have 9 times m minus 2. And by everything being multiplied, I mean that stuff with addition and subtraction signs are in brackets, separated and together. So because everything's multiplied on top, and I have a matching bracket and a matching bracket, that means that I can cancel out. And Ethan, you had a question as well? Multiplying the numbers inside the brackets and outside the brackets. I think I am misunderstanding your question. How do we represent multiplying the numbers inside the brackets and outside the brackets? Are you able to reword that for me, or maybe type a quick example? Because I think I'm misunderstanding what you're asking.
Let's say you have like maybe 6x over 6x plus 1 plus 5 over 4 bracket x minus 3. How do you represent multiplying the inside of the brackets and the outside of the brackets?
Sorry, my audio is just, let me fix.
You muted yourself.
Oh.
All right. So
for some reason, it's not coming through my headphones.
Okay. So let's say you have x over 6 bracket x plus 1 plus 5 over 4x, like bracket x minus 3. How are you supposed to represent multiplying the inside of the numbers on the inside of the bracket and the numbers on the outside? You're muted.
Gosh.
Right. Did you hear my question? The example?
Yeah, sorry. I'm just having issues with my headphones, and that's dead.
I'm going to mail you some new earphones.
Okay.
All right. Okay. So let's say you have x over 6 bracket x plus 1.
Why is my audio not working? Can you hear me?
I can hear you. Yeah.
Yeah. Okay. Is my audio working now?
Yeah, I can hear you.
Why is this not working? Disconnect. Is my audio working now? Sorry.
It was, yeah, it's working.
Okay. So what you're asking is if I had something like this. 5, like x plus 4, something like this?
6 bracket x plus 1, and there's like, but there's an x over it.
Where's the x go?
On top. Oh, it's x over.
Oh, like this.
Yeah. And then plus 5 over 4x bracket 4x minus 3.
Like this?
That the 4x minus 3, it's 4 bracket x minus 3. So 5 over that. There we go.
Like that?
How would you represent multiplying the inside of the bracket, which is like x minus 3 and x minus 4, and the outside of the bracket?
Oh, so like let's say I had to multiply these two things together to make a common denominator.
Mm-hmm.
So I would just do 6 x minus 4 times 4 x minus 3, and then I can simplify that. So then I could multiply these two guys together, and it would give me 24 x minus 4 x minus 3. Does that make more sense?
You just multiply it?
Yep.
Okay, thank you.
Yeah, sorry, it was a quick answer. I just was having a hard time with my audio.
All right.
Okay, so, oh, why is that not raising? Okay, so let's try our second example here, and we'll do that one together. And hopefully I can get my audio working because my headphones aren't working right now, so hopefully I can fix that. Okay, so let's do this second one together. And then, sorry, I just need to quickly plug in my other headphones. All right, so for the second one, the first thing that we're going to do is we're going to start by factoring the bottom. So that's always the first thing that we're going to do in order to get a common denominator. So let's factor out as much as we can. So we can't factor anything out of the top because it's just an x. And then on the bottom, we'll take the 6 out, and we'll have x plus 1, like that. And for the second one, I can't do anything with the 5. And for the bottom, we can take out a 4, x minus 3, like this. So all I've done is I factored out as much as possible. Yes, Jansen, you can unmute or you can type your question. Yeah, sure. We can find restrictions now. The restrictions from this step and this step will be the same. And the reason for that is because we've just factored it. So this represents the exact same thing as this. And this represents the exact same thing as that. So we can find them right now, but we can find them from the second one. So here, these restrictions would tell me that x cannot equal -1 or +3. And Dimitri, you have a question? So for our purposes, the easiest way to do your restrictions is to wait until it's factored. So once it's factored, it's much easier to do some restrictions. There might be some very special cases where you get something with a squared root. And if that happens, like it's in a homework question or something like that, feel free to send me a quick email and I can go over that with you. In general, your steps will always be to factor first so that we can see the restrictions nice and clear in these brackets. So that's our typical process. Okay, so now let's find our common denominator. So if I look here, I want to make these denominators match. So I basically need to think, what are my denominators missing? So my 6x plus 1 here is missing a 4, and it's missing x minus 3. Now, we can multiply it just like this. It's not necessarily going to be our lowest common denominator, but it's very straightforward. That's option 1. The other option is we can think of a common denominator between 4 and 6. If you went and straight multiplied it like that, you could still get the same answer. But our lowest common denominator between 6 and 4 is going to be 12. So how do I turn a 6 into a 12? I multiply it by 2. If I do that to the denominator, I must also do it to the numerator, like this. Now, let's think about our second expression. So we have 4x minus 3. So our lowest common denominator between the 6 and 4 is 12. So to turn that into a 12, I can multiply it by 3. And then it also needs an x plus 1 attached to it. So now I can just multiply the numerator by 3, x plus 1, like that. And now let's write all of that out. So we'll have 2x, x minus 3, all over 12, x plus 1, x minus 3, plus 15, x plus 1, all over 12, x plus 1, x minus 3. There we go. And now we can take a moment to double check our restrictions. So our restrictions are still the same here, so nothing new to add. So now let's add the tops. So remember, when we're adding and subtracting, we keep the denominators the same and we just add the numerators. So we'll have 2x, x minus 3, plus 15, x plus 1, all over 12, x plus 1, x minus 3, like this. And now, in order to simplify this in the numerator, we will have to distribute, and we'll have to expand, and then we'll collect some like terms to simplify it. So that will give us, 2x squared minus 6x plus 15x plus 15 all over 12 times x plus 1, x minus 3. So far, so good? Okay, and now we can try to factor, we'll combine the top, 2x squared plus 9x plus 15 all over 12, x plus 1, x minus 3. And that is our question so far. So now, again, we always need to double check our restrictions. So in this case, our restrictions are the same. Yes, Sasha, feel free to type your question. Wouldn't I cancel in the previous step? Okay, I'm so happy you mentioned that because this is a really good question. So we cannot cancel in the previous step, and here's why. I'm so happy you brought that up because this is a very common error. So because my numerator is not separated by just multiplication, because of this thing right here, we cannot just cross stuff out. Does that make sense? So If they were just all straight multiplied, then yes, but because of that addition, we can't. So I want everyone to be really mindful of that because that is the most common error with all of this stuff. And Tirth, can you type your question into the chat? And while that's being, shouldn't we? So that is the next thing we want to look into. This thing here, that's a great question, does not factor, actually. It doesn't factor at all, so you're actually done here. In general, I'll usually make things that factor and cancel out. So just as a FYI on the quiz and the task, you'll notice that things will cancel out. But in this case, this does not factor. If you try to start factoring it, it doesn't work. So for our purposes, I'll just tell you that. So we're not trying to find factors forever. Oh, it's okay. I hadn't got there yet. I was going to let you know. It's definitely not clear from the get-go. Ashal. Yes, exactly right. So here's the difference. Here's what it looks like when it's being multiplied. So for example, if I have x plus 1, x plus 2 over x plus 2, we can cancel there. That works. This is correct. We can do it. If I had something like this, it does not work because of this thing. So in that case, nope, we cannot cancel. So hopefully that example made things a little bit clearer. I think Dustin was next. While you type that, I'm just going to run and go grab my other set of headphones and be right back. So when the question says simplify, do we leave it as factored or standard form? So when it's a simplify, usually factored form is perfect. That's a good question. Okay, and Ethan, would you mind typing your question to the chat? Yes, so if it was factorable, we would have factored and we would have saw if there was anything we could cancel out. Most of your questions will be factorable on top in the task and in the quiz. And the reason why I typically make them factorable is because very often people will sit here trying to make it factor. And that is very time consuming to try to find out if something factors or if it doesn't. So all of yours will be factorable on top to keep simplifying and making them nice and simple. Just because if people start trying to factor and it's not working, they start really doubting themselves on a quiz. So I try to avoid ones like this on a quiz or a test. Okay, any last questions before we do the last example together? Then you guys are done for this lesson. Okay, these are all awesome questions, so I really hope that this is making things a little clearer. Okay, so let's do our last one, which is a little bit more intense. So we have 4 over y squared plus 5y plus 6 minus 5 all over y squared minus y minus 12. So the first thing we always do is we look to see if there are any restrictions right away. Because this isn't factored yet, the restrictions are very difficult to find. So what we'll do is let's factor first. And just to get some extra factoring practice, I'll factor them off to the side so we can do the whole factoring process together. So for this first one, we have y squared plus 5y plus 6. So we're looking for two numbers that add to our middle number, which is 5, and multiply to our last number, which is 6. So those numbers will be 2 and 3, 2 and 3. And because we have a y squared at the front, we can just write y plus 2, y plus 3. So now that we've done that, let's put that into our equation. So the 4 we can't factor, so it just hangs out as 4 for a little bit longer. And then we'll have y plus 2, y plus 3, like this. And now let's factor the other one. So we have y squared minus y minus 12, like this. So we need two numbers that add to -1, two numbers that multiply to -12. So in this case, we'll have -4, positive 3, -4, positive 3. And that will give us y minus 4, y plus 3. And now let's put that back into our equation. Minus 5 all over y minus 4, y plus 3. So this one here is a perfect example for talking about finding lowest common denominators. So our goal here, actually use a different color because I already used pink. Our goal here is to make our denominators match. So our first expression here has y plus 2 multiplied by y plus 3. So to make it match, that one is going to need a y minus 4. So if I multiplied that by y minus 4, I will also need to multiply the numerator by y minus 4. Now let's see what the other one needs. So we have y minus 4, y plus 3. So we will also need a y plus 2, like that. And if I did it on the bottom, I also need to multiply it on the top. So let's go through and simplify that. Then I can quickly do some restrictions. So I'll have 4, y minus 4, all over y plus 2, y plus 3, y minus 4. So I'm going to add a little intermediate step here. If you kind of wanted to skip already did the subtraction, that's cool. But I just want to include all the steps so everybody can see it all. Minus 5 times y plus 2 all over y plus 2, y plus 3, y minus 4. So now let's quickly do some restrictions. So if I look here, y cannot equal -2, -3, or positive 4. Okay, so the reason we're doing this one, and it's important, is because we have a minus here. So we just need to be extra careful of this minus, and you'll see why. So let's go through and add everything. Minus 5y plus 2 all over. Remember, when we're adding, we keep our denominator like this. Okay, so now we're going to distribute to simplify the top here. So we will have 4y minus 16 minus 5y plus 10 all over y plus 2, y plus 3, y minus 4, like this. Now, that negative in front of our 5y plus 10 bracket is very important because we need to make sure that that also gets multiplied in. So we will have 4y minus 5y minus 10 all over y plus 2, y plus 3, y minus 4. Now let's collect some like terms at the top. So we will have negative y minus 26 all over y plus 2, y plus 3, y minus 4. And that is our final answer. And we did our restrictions up there too, so we're all set. That's our final answer there. There's the whole thing. Are there any other questions before I send you off? Yes, Tirth, do you want to put your question in the chat for me? What units are there on the Unit 2 quiz? Oh, that's a great question. I'm just going to quickly write out this homework and then I will tell you. This is also on your outlines and on the lesson assignment. Okay, what units are there on the Unit 2 quiz? Great question. Oh, I realized it's wrong in here, so I'll just change it. It's just going to be all of yesterday's stuff. So 2.1 to 2.3a, which is basically today too, but there's none of the application questions on it. No problem. Well, have you submitted homework already? Awesome. Then you are done until our lunch meeting, and then we'll have another live lesson then. Yeah, Jansen. I'm just going to stop recording so the video isn't too long.